How do you convert from moles to grams? Let's look at a real-life chemical equation. There it is. This is the chemical equation for the combustion of butane with oxygen to form carbon dioxide and water. We will be converting moles of water to grams of water as we explore this reaction. It just so happens that I have a tank filled with butane right here. Now, chemistry isn't much fun if you don't do the reaction. So here goes, the reaction of butane with oxygen. Chemistry's great. And believe it or not, we converted the butane and oxygen into carbon dioxide and water. But where's the water? That's right, it was so hot that the water turned into water vapor, a gas. Now on with your question. How do we convert from moles to grams? It turns out that this tank has enough butane to create 82 moles of water. Please watch the converting moles to moles video if you want to see how I determined the number of moles of water we could make if we combusted all of the butane in this tank. So our starting mole amount is 82 moles of water for our problem. The question I have for you is, how many grams of water do we have if we make 82 moles of water? The first thing we need is the conversion from moles to grams for water. Do you remember the name of the term that tells you how many grams there are in 1 mole of a substance? It's called the molar mass. Let's look at that name, molar mass. Do you see that the word mass and mole are in the name? Literally, the name means the mass we have if we have 1 mole. So how do we find the molar mass of water? Because we need it to convert from moles to grams. All we do is add up the individual atomic mass numbers of the atoms that make up water, H2O. The periodic table tells me that oxygen equals 15.99 grams per mole, and hydrogen equals 1.008 grams per mole. For simplicity in today's discussion, we will round oxygen from 15.999 to 16, and hydrogen from 1.008 to 1. When you do the practice problems at the end of this video, or in your chemistry class, please don't round atomic mass numbers, unless your instructor says it's okay. Water's chemical formula has 1 oxygen. So I take the mass of oxygen from the periodic table, 16, and multiply it by 1 oxygen for a total mass of 16. That means that the 1 oxygen atom in the formula for water contributes 16 grams to the mass of 1 mole of water. Water also has 2 hydrogens. So I take the mass of hydrogen from the periodic table, 1, and multiply it by 2 hydrogens for a total mass of 2. That means that the 2 hydrogen atoms in the formula for water contribute 2 grams to the mass of 1 mole of water. Then I add the 2 together. 16 from the 1 oxygen atom in the formula, plus 2 from the 2 hydrogens in the formula. That equals 18 grams per mole of water. This is the molar mass of water, 18 grams per mole. In other words, if I have 18 grams of water, then I have 1 mole of water molecules. Let's use the molar mass of water to calculate how many grams of water we have if we have 82 moles of water. I need to use the molar mass, but how? Would you multiply or divide 82 moles by the molar mass? This is where some people guess and end up having difficulty. I don't want you to have to guess. Sure, I'll tell you right now that you should multiply 82 by the molar mass of water, which is 18 grams per mole. But how did I know that? What I really want to do is show you how you never have to guess whether you need to multiply or divide. Sure, it takes more effort, but the benefit is you will become very confident in your chemistry calculations. Here is what you do. You take what you are starting with, in this case 82 moles, and express it as a fraction. Now 82 written as a fraction is just 82 over 1. That's not tough. Then you make sure to write the units. Remember, we have 82 moles of water. Then you make a cross. This gives you another place for your next number to be written as a fraction and keeps everything neat. Easy so far. Now you write the other number you need, which we know is the molar mass, in the next spot. You write the molar mass so that the 18 gram part is on the top and the 1 mole part is on the bottom. Do you see that I've written the molar mass? It's written such that we would say 18 grams of water per 1 mole of water. There's nothing wrong with writing the molar mass like that. Now look closely. What do you notice about the mole units in what I've written thus far? Do you see that the moles from my 82 moles of water are on top, and my mole from the molar mass is on the bottom? When you have the same units on the top and bottom, they cancel out. What units are left? That's right, grams are left. What this means is that if we do the math as written here, we will get an answer with units of grams, which is what we want. So what is the math telling us to do? It's telling us to multiply 82 moles by 18 and then divide by 1. This is the same as multiplying 82 moles by the molar mass of water. So let's see what we get. The answer is 1,476, which we can round to 1,500 grams of water using significant figure rounding rules. Now, before we move on to the next problem, we should always ask ourselves, does this answer make sense? Recall that this tank will produce 82 moles of water. And remember that we have 18 grams of water for every mole of water. So it makes sense that we'd have 1,500 grams of water as our answer. Checking to make sure our answer is correct is an important step. Now let's see what would have happened if we had done the problem with the molar mass flipped. This would have been bad. Do you see that with the molar mass flipped, 1 mole of water over 18 grams, we don't have the moles canceling each other out. We have moles on the top in each fraction. So if we did the math as suggested in this setup, we would have an answer with units of moles squared over grams. What is that? It's nonsense. When we set up our problem with this method, if we don't have the correct units in our answer after canceling units, we know that the problem has been set up incorrectly. This method allows us to be aware of when we've set it up incorrectly before doing all the math. By the way, the method of using fractions and canceling units is called dimensional analysis. By practicing with it now, you'll have a much easier time with more complex calculations later as you continue to become a more powerful chemist. I'll leave you with some worked out problems. You try the problem, then pause the screen before looking at the answer. If you can do these problems, then you shouldn't have any issues converting moles into grams.